Going over the short by 8. For number 1, you needed to simplify using the distributive property. So this would be 10x minus 14. Bring down your 3x, and then combine your x's to get 13x minus 14. Number 2 asks, is this relation a function? So every x in the domain has to have one y value in the range. If an x has more than one y value in the range, it is not a function. So this has one, this has one, this has one, this is a function. Number 3, you needed to find the slope of the given points. So remember to use your y2 minus y1 all over x2 minus x1. So 4 minus negative 2 all over 5 minus negative 1. This would be 4 plus 2 and 5 plus 1, which would simplify to just be 1. You have any questions on those 3? And then on the back, number 4, you needed to solve. To distribute twice. To get negative 6x minus 15 plus 4x minus 36 equals 1. Combine your like terms. And solve for x. So x equals negative 26. The very last one asks you to state the domain and range. So domain is your furthest point to the left and the furthest point to the right. So here on the left, it starts at 0, and then it keeps going to the right. So you can write this one of 2 ways. X is greater than or equal to 0, or from 0 to infinity. For your range, this keeps going down, and this keeps going up off the graph. So your range would be all real numbers. In interval notation, in set builder notation, that would be this weird notation. Or you can write it in interval notation. To mean from negative infinity to positive infinity. Remember that all of these are good algebra review practice, and that you should be practicing all of these. Do we have any questions on these? Today we're going to start the 3rd lesson of notes in inequalities, and that's graphing inequalities. So you should have those notes in front of you, and they should look something like this. So as I mentioned when we started inequalities, that this is going to be similar to how we graphed just regular equations, but a little different because the inequalities mean different things. So in order to graph an inequality, you need to know the rules on how to do so. If it's not in slope-intercept form, you need to write it in slope-intercept form. So that's kind of the same as a regular equation. And then we graph the inequality like normal. Plot the y-intercept, find your slope, plot as many slope points as possible. But before you connect the dots to make a line, this is where the inequality specifics come in. So if we have a strictly less than or strictly greater than sign, we're going to use a dashed line. So it's not going to be a solid line like we usually draw. It will have spaces in between them. But if we have a less than or equal to or greater than or equal to, we're going to use a solid line. So that would be like the lines we usually draw. And then even further, we have more inequality rules. If we have less than or equal to symbols, we need to shade the graph. Because remember, inequalities give you a vast majority or amount of solutions. So everything less than or equal to could be a solution. So we're going to shade the graph below if it's less than or equal to. And if it's greater than or equal to, we're going to shade above. So that means everything in the shaded area could be a solution. It's kind of the equivalent of us drawing arrows on a number line. Before we actually get into some of these examples, do we have any questions on any of those rules first? Let's do number 1. So it's in slope-intercept form. For the most part, it doesn't have an equal sign, but we're ignoring that part. We can start this off as any other equation. Start at your y-intercept of -5. Plot a point there. If you need rulers while we're doing this, they're in the colorful part. And then your slope is a positive 1/3. Remember, when we graph slope and it's positive, we can go up and to the right or down and to the left, but we have to go up or down first. So I can go up 1 to the right 3 and do that as many times as possible. And then go down 1 to the left 3 as many times as possible. Then we have to decide what type of line is this going to be and where do I shade. So this is a strictly greater than. Would this be a dashed or a solid line? Dash. So you could do one of two things. It's dotted right now, so if you wanted to just draw arrows at the end, you could do that. If you wanted to make it a little bit more dashed, you could like put dashes in between. Either or. So we know it's going to be dashed, and then this is a greater than symbol. So would that be shaded above the line or below it? Above. So if you're not sure where exactly above or below is, I would start at the y-intercept and go above or below that point. So above this point would be up here, so that means everything would be up here. You can completely shade this area in. You could like draw lines, lightly shade it. Doesn't matter. Because as long as you know that this area right here is your shaded area. Yes, you have to shade, otherwise it's not an inequality, it's just part of it. So after you get your graph and it's shaded and we've done all those things, now I'm going to put shaded over here. The next thing is to determine, are the following points solutions or not? So the easiest way to see that is you can plot them, but you don't have to. I'm going to plot them just so we see them. 0, 0. If it falls in the shaded area, it's a solution. If it doesn't, it's not. So 0, 0 would or would not be a solution.
Would not.
Is 0, 0 in the shaded area?
Yes.
Yes. It would be a solution. 0, -5 happens to fall on this line. Things that fall on the line and when the line is dashed would not, but to check that, you could put this point into the equation. 1/3 x minus 5. Oh. So if I put in 0 and -5 into x and y, this would be -5 is greater than 1/3 times 0 minus 5. This becomes just -5. Is -5 greater than -5?
No.
No. So then that would not be a solution. Even though it falls on the line, it's not a solution. If that line was solid, then it would be a solution. And you could check that and it would work. Three -2, is that a solution?
Yes.
Yes. 5, -6. No. And -7, 6, 7, 3.
Yes.
Yes. If it falls in the area, it is. If it doesn't, it's not. Sometimes, depending on how you shade or what colors you shade with, it's hard to see your points if you draw them. As you're practicing, Desmos has different colored points and lines. So I would put in your inequality, put in different points, and see does it fall in the shaded area or not. Right now, do we have any questions on how we graphed this inequality or found these solution points? We're going to do 3 more, maybe if we get them, but on the next page. So number 3 is now not in slope-intercept form, so we would need to convert it before we do anything. Subtract 5x to the other side. And divide both sides by -2. Remember that when we divide by a negative, the sign changes direction. So y is now less than positive 5 over 2x minus 6. Once you have your inequality, you can graph it. Your y-intercept is at -6. Your slope is 5/2, so we can go up 5 and to the right 2 as many times as possible. This would be a dashed or a solid line. Dash again, because it's strictly less than. And would this be shaded above or below? If it were greater than, yes. But this one's less than, so below. And if you're not sure, go to your y-intercept. Below would be down here. So it would be everything underneath. Or this area right. The last part says, write one ordered pair, there'd be a solution. There's many. Someone give me one. Alex.
4, 1.
4, 1. That's not the one you wanted, and you like 7, 0, go for it. Or 7, -7, 7, +7. As long as it's in the shaded area, it doesn't matter. Questions about that? Let's jump to number 5. Same thing. It's not in slope-intercept form. We need to get it in slope-intercept form. Subtract x to both sides. And divide both sides by -1. Or everything by -1. So our new inequality would be y is less than or equal to, because my sign flips, positive x minus 8. And then I have to start at my y-intercept. This is a 7 by 7, so kind of make it off the graph. And then I have a positive slope, so I go up 1 to the right 1 as many times as possible. Would this be a dashed or a solid line? Solid. So I could connect these dots like normal. Whether your line is solid or dashed, make sure you have arrows. And then would this be shaded above or below? Below. So here, below this would be down here, would be down here, or in this area. Someone give me a point that would be a solution.
-7.
-7 what?
4.
-7 4 would be a solution. This one right here. No. Switch that.
-5.
Would that be a solution?
5 negatives.
5 negatives. 1, 2, 3, 4, 5. That would be a solution. Would 7 negative 1 be a solution? I see some no's. Let's check it. Less than equal to x times I said 7 negative 1. So you can check this for any point that you have, either in slope-intercept form or standard form, does not matter. I'm going to put this in, so I have negative 1 is less than or equal to 7 minus 8. This would give me negative 1. Is this true or false? True. So 7 negative 1 would be a solution. So when it falls on the line and it's a solid line, this would be a solution. Have any questions on that one? Let's do one more, and then I'll let you guys practice. For 7 and 8, you need to remember your bucks. So horizontal lines have 0 slope and are y equals, or in this case, y inequalities. And then vertical lines have undefined slope and are x equals or x inequalities. So number 7 is going to be a horizontal or vertical line? Horizontal. At negative 4. I'm going to put a point at negative 4. This would be a dash or a solid line. Solid. So I would draw a line all the way across. If it was dashed, I would just make it dash. And then would this be shaded above or below? With y inequalities, it's really easy to see above or below, because it's this one or this one. So a point in there could be anything from negative 7, what was that, negative 4 below, and to 7 negative 4. With your x's, when you draw it, when you're thinking shade above or below, you're really shading to the right or to the left. So you have to think about like your number line. When you would draw it, greater than would be to the right, less than would be to the left. Okay. I want you to take the next little bit, actually for the rest of the class, practice the ones we did not do. So numbers 2, all the even ones, 2, 4, 6, 8. And let me know if you have any questions or need help with any of those.